Hey guys, welcome back. In this video, we'll be looking into uh, the ISIS protocol, right? We'll be talking about these various concepts, the characteristics, implementations, right? Some of the advanced implementations involving level 1 areas, level 2, level 1 to metric, authentication, summarization, and route leaking, right? Great. So to begin with, ISIS is actually an IGP, right? It's a link state routing protocol, which is similar to OSPF. It forms neighbor adjacencies. It has areas, right? It exchanges the link state, updates, builds a link state database as well, and runs the Dijkstra's shortest path first algorithm as well, right? Some history with ISS, I would say back when OSPF and ISS were being developed, IP wasn't like very dominant protocol, right? So people, when people think of OSI, they automatically think of OSI model. But back then, you had something different. You had something called as the International Organization of Standardization, right? Also, and they created something very similar to IP, which is which is basically called as CLNP, right? Connectionless node network protocol, right? So there is connectionless network protocol, right? So ISS was actually developed to kind of like support both the protocols, right? It is and the ISO, they use slightly different terminology. Like for router, they call it as intermediate system, and that is how the ISS name was born, right? So ISS here basically stands for intermediate system, intermediate system. So it's like trying to connect to intermediate systems, right? So ISS was originally developed, mainly for CLNS, not IP, and that's why I would say that's a really good advantage as well. It turned out to be a very good advantage, right? And obviously later ISS was adapted, widely for IP as well, and it started being called as the integrated ISS. Now I'll tell you why this is very good, right? On the advantage part of it, right? So ISS is very highly scalable routing protocol, right? So the scalability, it's because it's much easier to build large networks with ISS than it is with OSPF, right? So scalability. Now the other part being how ISS actually has kind of like an agnostic approach to the data it carries, right? So ISS carries a payload of reachability data, but for most part it doesn't care what's there in the payload, right? This makes it very useful for protocols such as fabric path, right? In contrast, OSPF always carries the IP routes. So OSPF you can always use in a IP domain, whereas ISS you can use like irrespective of what kind of routes it is, right? What kind of addressing you are using. You can use it for CLNS, you can use it for IP, and maybe tomorrow we have a new standard, we can use it for that as well, right? So other interesting thing you can note here is that OSPF, when you start using it for, let's say, IPv6, right, they had to rewrite all the RFCs, and that's why OSPF version 3 was born. But in case of ISS, you don't have such issues. You run IPv4, you run IPv6, you run CLNS, everything is going to be taken care of in ISS, right? So if you look at the header, it's pretty interesting, right? For ISS, you don't have an IP header, right? So you have the ISS data, then you have kind of like a custom ISS header, right? And that is basically directly encapsulated in your layer 2 protocol or layer 2 header, right? Unlike OSPF, in OSPF you are going to have like a OSPF packet which is encapsulated in your IP header, and then that will be encapsulated in your layer 2. But here you don't want the IP header. It is the ISS basically, or the ISS packet is directly encapsulated in your layer 2, right? Great. So start with yeah, I think we can get started. There's actually something which I wanted to talk about, the network entity title, right? Basically the addressing scheme which we use in case of my ISS, but I'll show you that when I start doing basic configuration, right? So let's start doing basic configuration. What I'm going to do now is I'm going to create an area. Let me put a probably let me put a box here, so that maybe let's color it with red. right? So the box, right, let's put it here. And what we are trying to do is we are going to create like an area over here, right? ISIS area basically, right? I'm not sure if this is seen. Let me scroll it a bit down. Yeah. So we're basically going to create an area with three routers, R1, R2, R3, right? And let's see how we can establish ISIS in this area, right? So let's start with I have some basic configuration on these routers, right? So this is my R1. If you look at let me clear the screen, show IP interface brief, right? So I have some basic configuration, and let's go and configure my ISIS. So how do you configure? Let's start with router ISIS, right? You enter the mode, and now every single router in ISIS you need to give something called as a net value, right, or the network entity title, right? And this looks like a very big number, but it's actually pretty simple, right? So this number has three sections. The first one is the area ID, right? So the area ID is variable in length, but must at least have like 1 byte of data. It is often like a 3 byte value, right? That's generally which is used, right? The first byte is what you call as the address family identifier, and this is often set for 49, for ISS, right? And so basically you start with putting in 49 because that is what is used for ISS. And the next part, right, is basically I told you it's a 3 byte value, right? So the next value for OSI value for the private addressing, you use 1, right? So this is basically something which is going to change based on the area, right? Because we are talking about area 1 here, right? I'm going to probably gonna use 001, right? Later if I want to change, and I'm probably doing it in a different area, I can change this, right? The next part is the system ID, right? So say system ID. So system ID needs to be a unique value within the area, right? So for this router it should be unique, for this router it should be unique. It is basically used to identify the router, right? So I'm going to use a system ID of what I'm going to use, because it's a R1, I'm going to use 4 ones, another 4 ones, another 4 ones, right? 6 bytes, 6 bytes of data, 6 bytes is the system ID. And the last one is the N cell value. This has a special meaning in the OSI stack, but for ISIS it's always set to 00, right? So if you look at it, the 49 and this 00 will always remain constant, right? Whereas this part is something which is going to change. This will change based on the area, and this will change within the area, it will change based on the device as well. So it looks like a very big number. When you break it down, it's pretty simple. So that's your net value, right? Now we just go and enable ISIS. How do you do it? You go to the interface where you want to enable. In my case, interface Ethernet 0/0, and I would go for IP router and ISIS. Similarly, I go for interface Ethernet 0/1 because I have two interfaces here. Let me enable that as well, right? Probably I have a loopback as well. I can see a loopback. Let me do that as well. So there you go. So I've enabled ISIS on all my interfaces on R1. Right? Make sense? Now let's go and do the same thing on my R2. It's very simple. Now that we know, you can do show IP interface brief. Do I have my network? Yes. So I can just go down here, router ISIS, right? Router ISIS, and what else? The net value, which is 49.001, because 01, because it is still the same area. The next is my system ID and cell value, right? And what else? I need to do this on Ethernet 0/0. I'll do IP router ISIS. Let's also do this on interface Ethernet 0/1, right? The same thing, IP router ISIS, and probably on the loopback interface as well. Make sense? Great. So we have done this on R1 and R2 now, right? We have just enabled it. Should we see some routes on R2? Let's look at this. Show IP route. Yeah. let's make this very specific to ISIS. Let's see ISIS. Okay, let me clear the screen a bit. It looks a little bad. There you go. What do we see? We see the routes from coming in from my R1, right? I will tell you what this L1 stands for, but let's just concentrate on this for now. We can see that we have established ISIS, between these two guys, and you can see the routes coming in from R1. Similarly, on my R1, I should be able to see my routes from R2. So if I do show route ISIS, sorry, show IP, my bad. Right, you can see the ISIS routes. The I over here stands for ISIS. Right, let's continue and enable it on my last router, which is my R3 here. Right, enable show IP interface brief, configure router ISIS net value, which is 49.001, then 33, okay, and the last one is 3 and 00, interface Ethernet 0/0 we gotta do, and then what, IP router ISIS. Right, let's move on, interface 0/1, right, same thing, IP router ISIS, and the last one is interface loopback 0 in the router ISIS. There you go. So you have enabled it everywhere now, right? We could check the routes on my R3, show IP route ISIS. There you go. We can see the routes of R1 and R2 coming in here, right? So that was how you basically, kind of do a very basic setup or basic configuration of your ISIS, right? We have just configured only one area over here, right? And that is what we did. Now going ahead, now let's talk about what are these L1 and stuff which appear here, right? So in ISIS, the neighbor relationship is formed in three ways, right? So you can form like a level 1 neighborship, you can form level 2 neighborship, or you can form kind of like, or you can basically have you can have two routers where you're forming both the relationships or the neighborship as well, right? What I mean by that, between R1 and R2 I can have a L1, or I can have a L2, or I can have both L1 and L2, right? Now what is this L1? L1 is mainly for intra-area communication, right? The whole idea of link state protocols is that every single router in my area should have all the link state information, right? Every single routes, it should know about it. That's the whole idea of link state protocol. There's a main difference between link state and the distance vector routing, right? So within the area, within the local area, the routers need a complete information, and that's why you can use the level 1. Now level 2, it is mainly for inter-area communication. So let's say I have another area over here, maybe let me put this up, we can use it in future later. Save, right? Let me put a box here, because this is basically going to be my other area, right? So you see this is my area 2. So now if you want to communicate between area 1 and area 2, right, I'm just using the terms area 1 and area 2. There is nothing like area 1 and area 2 in ISIS. I'm just using it just to separate these two areas. The areas are basically decided by the net value itself, right? We have an area ID over there, right? I showed you that earlier, right? The net value over here. So this is what which decides the area. Anyway, so if you have two areas, now if you want to communicate, right, in between them, right, so in that case what happens is, let's say in this case R3 is my ABR, right, area boundary router. So it will kind of like summarize all the information, right, for this area, and it will send here, right? So it is summarized. When I say summarize, it will summarize the LSPs, right? Just like in OSPF we had an ABR which was summarizing the LSAs, right? Similarly here you're going to summarize the database what you have, right, the level 1 database, right? If you have kind of like a level 1 relationship, basically it will summarize all the information from its database, from the ISIS database, and it will send it to my other area. That's level 2, right? So every single router you can configure it either as a level 1, level 2, or level 1 or level 2, and based on that it will form the neighborships, right? Now by default in Cisco routers it forms kind of like level 1 and level 2, right? So each of the router is level 1 and level 2. So I can show you that. So if I go down to my, let's say, R1, and if I do show ISIS neighbors, you can see here R1 has formed L1 relationship with kind of like R2, and it has also formed L2 with R2, right? Both L1 and L2, right? Now if you want to look at the level 1 database, right, it's very interesting to understand ISIS if you're trying to compare it with OSPF. And so basically you'll have to look through my previous videos on OSPF, because it becomes very easy to kind of compare and learn, right? So now if I want to tell you about the level 1 database, right, or the level 1 neighborship, right, how it kind of level 1, I would say it kind of translates very closely to the type 1 and type 2 LSAs which were there in my OSPF, right? So let me show you. So if I have if I do something like show ISIS database level, what level are we looking? Level 1. And if we do detail, sorry, right, if we do this, what we are getting is we are looking to what's happening in level 1, right? The information in level 1. The information in level 1 is very similar to what we had like type 1 and type 2 in OSPF, right? And so we can make understand of this, right? In this above segment, right, what you see here is where is this? So this is R1, you have R2 here, and you have R3 here, right? Give me a minute. Yeah. So what are we looking at? So R1 is advertising two networks, the connected networks, basically 12 and 17, because we have advertised or we have enabled ISIS here. 12, 17, and obviously the loopback, right? Now what is R2 doing? R2 is also advertising my 192, 12, 23, and 2, right? These three networks, right? Isn't that information very similar to what we had in type 1 LSA? Type 1 LSA was basically that, right? Wherein every single router was basically advertising or showing off what is connected to that particular router, right? So that's very similar. Now what else? What other information can we derive from this? It is also telling me this R1 is connected to the segment R2.01, right? And you can see on my R2, what is happening on my R2? R2 is also telling me that it is connected to the segment R2.01, right? And just like in OSPF, you don't have designated router, but you call this as a DIS over here, right? So you have something called as a DIS, and you have the same concept of election and all of that happening, right? And between, so if you look at this segment here, you have segment, this is one segment and this is a second segment. So between R1 and R2, this is one segment, second segment. So between R1 and R2, we will have one DIS, and in this case, R2 is the DIS, right? How did I get to know that? It's a very nice trick. So if you look at the segment ID, so this is a segment ID, right, for the segment ID over here, right, R201. So if the segment ID basically takes R2 as the name of the segment ID, it's very clear that the DIS is basically R2, right? So coming back, we saw what is type 1. Now for type 2, you can see that R1 is telling that it is connected to this segment ID. R2 is telling that it is connected to this segment ID, and R2 being the DIS confirms, right, that this segment ID R2.01 is actually having these two routers, right? Because if you remember, type 2 LSA was basically the validation LSA, right? So what I'm trying to do is I'm trying to compare my OSPF with ISIS, right? And now don't you think using this information what I have, can't I reconstruct my topology? I can, right? And this kind of L1 database is spread across all the three guys. It's given to R1, R2 has it, R3 also has it. So any router, just by looking at this database, they can figure out and they can reconstruct the topology. And that's why ISIS is a linked state routing protocol, because every single router has a clear view of what's happening in the topology, right? Clear information, right? So that was basically level 1. So this is how you look at the level 1 database, right? we saw this. So we just go down ISIS database level 1 detail. What about level 2? Right? So when you enable L2 on R2, so do we have any L2 here? Yeah, I told you that every single router by default has been enabled for this. So I can show you the level 2 as well. So let's look what is there in level 2. So show ISIS database level 2 detail. Right? So I told you level 2 you use when you want to communicate or you want to kind of like summarize all the information in my ISIS database to the next area, and that's what exactly you see here, right? And because in my topology, like I said, every guy is L1 L2, right? So every single router is ready with the L2 information in case someone tries to or forms a L2 neighborship with them. Maybe tomorrow I might simply come and connect a router here and connect a new area over here, right, to R2. So R2 will have to share all the L2 information with that router, right? So it's all ready, always ready. I mean, or by default, it is L1 and L2. So that's why it's always ready. So you can see here R1, it is telling that these are the networks in my area. You wanna connect to my area, you wanna do anything, these are my networks. Right, you can see the same networks are again advertised by R2 as well and R3 as well, right? So because all the three guys are L2s, right, all the three routers have L1s as well as L2s, right? That's why you can see all the three are having the same L2 database, right? Now coming back to the topology, right? If you look at it, do you really need all of this information, right? Do you really need L1 and L2 in your area? Actually no, right? We are basically using a lot of resources and wasting a lot of resources, because every time a router is configured as L1 L2, it has to form two set of neighborships. We saw this earlier, right? We saw this. It has to form two set of neighborships. It has to maintain two separate databases. Imagine a big network with lot of routers, and there will be a lot of churn, lot of CPU will be wasted, right? So do you really need two separate levels on a single router? You don't. So that is where the intelligent designs come in, right? You have to design your network in such a way that you reduce all this overhead, right, by limiting the number of levels, right? So going back now, in my this particular area, you see that my R1 R2, right? Let's forget of R7 for now, right? Let's just look at R1 R2 R3. So R1 and R2, let's assume, because R7 is not there, this is kind of like the end of the network, right? You don't have anything else connected. If you forget about R7, there's nothing else connected to R1, right? So this is kind of end of the network, right? So how about we make R1 and R2 like the level ones, and R3 obviously it's going to be L1 L2. But will it work? Will if we change this R1 and R2 to a different area, right? If we limit it to one particular area, that would kind of reduce the overhead, right? Because we will no longer have L2 relationship between these guys. Currently we have L2 L2 L1 L1, we have like everything. But I really don't want that. What I could do is I could probably go down to my R1, I go down to my router ISIS, thing happened, yeah, ISIS, and I can do IS type, right? This is how you can change the level. I'm going to say level 1. Same thing I can do on my R2 as well, right? So I'm going to do IS type level 1. So once I do this, right, it's going to take some time, probably show IS as neighbors. Yeah, it's going to take some time to come up because it's IS, it takes a bit of time. But what I've done, I've just limited it to L1. I've removed the L2 now. Takes a bit of time. Let's wait. Yeah, so you see now it's up. So now earlier we had two relationships, but now we have just one relationship, only L1, right? So between R1 and R2 we just have the L1 relationship, right? whereas between R2 and R3 also we will have just the L1 because we have just enabled L1 on R2, right? But on R3 you have L1 and L2, which means later when I talk to the other area, they'll be able to form like a L2 relationship, because between areas you need to compulsorily have like a L2 relationship, L2 neighborship. You can't have L1s, right? Using L1s you can't communicate between areas, right? But within the area you really don't want to have multiple relationships and multiple databases. Now if you look at this show ISIS database, right, the level 1 will still remain same, right? I can show you that. See, the level 1 still remain the same, but will level 2 be there? Let's check that. See, there is nothing in level 2, right? So we basically ended up saving a lot of resources and a lot of CPU and all of that, right? Now let's moving ahead. What we'll do is we'll look at multiple areas. So this was one area. Now let's look at the multiple area concept here, right? So what did we understand now? We generally inside the area we make it L1 relationships, right? I will also talk about some very rare other kind of cases where you probably might have another area connected here, but for now imagine this is the dead end, right? There is nothing else connected to R1. So in that case you generally make kind of like a L1 relationship between these routers so that you don't have L2 databases and all of the resources being wasted, and only on the edge router you can make it L1 L2, right? So that you make it L1 L2 because from the L1 side you get all the information, all the connected routes, all of the specific routes are obtained in my L1, and L2 will help you to translate that to the next area, right? So now let's go and configure my R4, R5 and R6, right? So R4, what is R4? That's in my other area, right? If I do show IP interface brief, you can see what's happening. Yeah, so let me go here, router ISIS net. Now 49 remains same. I told you we are in a different area now, so we'll put in 2, right? We were earlier using 1, let's use 2. Not compulsory to use 2, I'm just using 2, right? And the system ID should be unique, so let's do this. Once we have done that, let's go and enable Ethernet 0/0 IP router ISIS interface Ethernet 0/1 IP router ISIS interface loopback 0 and IP router ISIS. Good. Right. Now what kind of relationship would be formed here? If you look show ISIS neighbors, you will see that L2 kind of a neighborship has formed between R3 and R4, because R3 and R4 are in different areas and L2 is the only way they can communicate to each other, right? Though we have made this one L1 and L2, L1 and L2, they won't form L1 because it is in different areas, right? Did R4 get the routes? Let's check that. Show IP route ISIS. What kind of routes has R4 received? Right, or probably let me clear this. Right, you can see here it has received the routes from my R3, right? It has received the 1 network, 2, 3 and all the networks which was there in my area 1. But you see here it is it's got the routes, but it's not very specific routes, right? It's not very specific routes. What I mean is route SS, right? Yeah. So R3 has actually summarized. This is, you can see here you have a mixture of L1, L2, L1, L2, right? So the L1 routes were all learnt within the area, right? These are all learnt within the area. But when they went to the other area, everything became L2, right? Kind of like it tried to summarize its own database and send this summary kind of summary of the link state updates to my other area, which is R4, right? Let's continue enabling it on R5 and R6. Let me do this quickly. It will be 2, and interface Ethernet 0/0. Right, so we have on 5 done. Let's do it on 6. Like that. The area number 6, and we will go and do right. There you go. So we have enabled, we've done the same thing which we did earlier, but we have done it on R4, R5, R6. Right. What we'll do is on R5 and R6, let's enable it very specific to level 1. Right. So we'll make it IS type, sorry, router, because we learned, right, why are we doing this? To reduce the churn, to reduce the resources being wasted. So I really don't want level 1 and 2 on all the both these guys, because let's assume that this is like the end of the network, right? Why do we even want we won't be like giving these routes to anyone else. So this is kind of like the end of the network, more like a stub, right? So that's why I'm very good with just enabling L1 on R5 and R6, whereas my boundary routers, right, AVRs, they will have L1 and L2, right? So if I do IS type level probably 1, gotta do the same thing on my R6 as well. Router IS, there you go, done. Great. Now something which I want to point out, what did we do? We set up this whole thing, right? And because we have now a L2 relationship between these both guys, so you have the L2 routes going from here to here and L2 routes going from here to here, right? Now these L2 routes, how will they appear on my R2 and R1, right? When let's say the routes which are learned from here, 4, 5, 6 will be visible on my R3, right? Because it is the ABR, right? If I do now show IP route ISS, you can see here we will okay, it's still not yet come up. Yeah, now you can see you have the 4 and 5 appearing on my R3, right? The 4 and 5 4, 5 and 6 as well should come. Yeah, the 4, 5 and 6 are visible on my R3, right? But will they be seen on my R2 or R1? Let's check that. Show IP route ISS. You can see you don't have 4, 5, 6 here, but instead you can notice there is a default route which has been added, right? So this is a very good learning. What is happening is, when the L2 routes are learnt by, say in this case R3 is learning the L2 routes from the other area, right? It will not send the L2 routes to R2 because they don't have a L2 relationship. They have just L1 relationship here, right? So it will send a default gateway to R2, and R2 also will then propagate this default gateway to R1. So if you look here, there is a default gateway which got added, right, on R1, and you'll have the same default gateway on my R2 as well. Here you go, see, you have the default gateway, right? So only R3 will have all the routes, all the L2 routes which has come in, but it won't give the specific routes to these guys. These guys will just end up having the default gateway, right? Great. Now the next piece which I want to talk about is there are two types, really funny names I must confess. There are two types of routings. One is called as the cold potato routing and the other one is the hot potato routing, right? So in the cold potato routing, what happens, it's basically the other name for suboptimal routing, right? So this kind of methodology where I told you, the default route gets propagated to the routers and not the specific routes, this is not really good if you have like a segment, or if you have a network which is which has multiple ABRs or multiple edge routers. In this case it works fine. In this case there is no issue. But if you have multiple edge routers, let's say R3 is here, probably there is one more R4 here, right, which is also the edge router, then it is it creates very suboptimal routing, right? Because what will happen is if you have multiple edge routers, then both the edge routers, let's say here you have an edge router here, you have an edge router in this area as well. Now what happens, the edge router here will forward or will inject a default route into this area, and R3 also will inject. So you'll have like two default routes getting injected, right? So at R1 you will basically end up getting two default routes, right? But R1 will obviously pick only one default route from the database and put it in its routing table, right? So for some of the routes, when it was supposed to go through the below router or whatever is down here, it will not go. Instead it will go through the top one, right? And basically it will end up creating a suboptimal routing. You can test it as well if you want. You just need to add one more router here, right, and kind of like connect it to R1, and you will see that that basically is seen in a network where you have multiple endpoints, right? Here you have only one, so it's not an issue, right? So it creates a lot of it creates cold potato routing or suboptimal routing, right? So we can fix this, right? By fixing, I mean you don't want the default route on R1. Currently we have just the default route and we don't have the specific routes to 4, 5, 6, right? We just have the default route. So by fixing it, I mean you want to kind of like get more specific routes on R1, right? So to do that, you can do route leaking, right? So route leaking is, in this case, it's basically redistributing my L2 routes into L1. So I know my L2 routes are on R3, right? And they are not getting redistributed on R2 because they have a L1 relationship here. But if you want to force this redistribution, you can do that using route leaking. How do you do this? Go to R3, clear the screen, configure. Let's create an access list. Call it 101 and a permit IP any. Sorry. Right? Now we go to router ISIS and we do redistribute. Redistribute what? Redistribute ISIS IP level. What I'm redistributing, level 2 into level 1. Level 2 are the routes which I learned from the other area, right? I'm redistributing into level 1. Distribute list, you need to use this access list number, which is 101. Here we created this, right? There you go. Now we'll see the difference. We'll go to R1. So this was the routing table earlier, right? But now you can see the routing table increased. It's no longer just 2, 3, but instead you have 4, 5, 6, the more specific routes coming in from my other side. So now it will not take the default gateway, right? If you want to ping say 4.4.4, it will actually take one of these paths. It is going to take a more specific route, which will be there in the routing table. So it is more optimal, right? You won't have the issue about suboptimal routing or the cold potato routing. So this is literally called as the hot potato routing, because you kind of made it more specific, added more specific routes. So that's something which I wanted to show you, right? Should I do route leaking always? No, not exactly. It depends on your topology. If, like I said, if there is a single edge router, then it's not needed, right? But if you have multiple edge routers, then probably route leaking is one approach. The other approach which I would say is to solve the same problem. The other approach I would say is to make all my routers as L2, just L2, right? So let me remove this redistribute part which I did just now, right? So this was my redistribute part. Let me put a no here, right? Did a no. Now let's see my routes, right? It's gone back. R1 is got back to its original state, right? Yeah. So I was telling the problem here was that my L2 routes were not coming in R2 because L1 because my R2 kind of was a L1 router, right? And L1 doesn't form neighborship with L2. What if I make L2 what if I make my rest of the two routers as well as L2 or level 2. In that case, all the routes would get propagated, right? And I would still have just one database. I wouldn't have the L1 database. I'll still have just the L2 database. So it's optimal as well. We are not wasting resources, right? So if I go back to my R1, let's clear this. To router IS type, right? Let's change it to level 2. By default it is level 1 and 2, right? I've done it on R1. Let's do on R2. Level 2, and the other guy as well, right? Level 2, right? So all my three guys, R1, R2, R3 are level 2 now, right? So if I look at my R2 and do a show IS neighbors, still not yet come up. Let's wait for a minute, take some time. Yeah, so you can see on one side it has come up. I hope I did level 2 on all the sides. So I did level 2 here, R1. It's come up on R1, but it's still not come up here. R2. Yeah, now it has come up. So you can see L2 has been established between both the guys, right? And we just have L2, we don't have L1 anymore. So now if I go on my R1 and let's look at my show IS database level 2 detail, right? You can see I have my level 2 information, all the information regarding what router is connected to where, right? What networks are being advertised. I have all this information. I also have the information coming from R4, R5, R6 as well here, right? Is my yeah, so I have that. Let me see this. One sec. Yeah. 3 R4. Yeah. So I have all this information, which is basically the level 2 details on my R1. At the same time, if I look at my routing table, right? Show IP route IS. If I do this, you can see I have the specific routes. I have 2, 3, 4, 5, 6. I have connectivity, right? It's no longer the default route, right? So we kind of can fix that problem which we had with the default route or the suboptimal routing two ways. One is by doing route laking like we did earlier, redistributing my level 2 routes from my obviously the area border router or the edge router into my level 1, or the other option is make everyone L2. Make everyone L2 so that whatever L2 routes you learn from R4, it will be transferred or it will be propagated. Everyone has the information like this, right? So that's something interesting. The other part which I also want to show you is there is obviously flexibility to enable the level under interface as well, right? So in this case, let's say R5, right? On the R5, you probably want one interface to be in level 1 and the other interface to be in level 2. You can do that. You can just go under the interface, type in the command IS circuit type, and you can change the levels as well, right? Just for information, right? So now what we'll do is we will actually do let me wipe this configuration. Let me stop this, and so what we'll do now is we'll do one big topology, and we'll basically configure we'll configure end to end, right? The ISS, like we'll configure multiple areas and we'll do the whole stuff, right? Probably that will be coming up in the next video, right? So so that it's not too much, right? So we'll be doing that, okay?